Evening everyone. Today we are presenting our project on an intelligent braking system using Arduino. The system is designed to automate the braking process in vehicles and enhance road safety by reducing human error. I'm Alvin Nathan, Analakirti Nathan, the project lead, and I'll be guiding through this presentation. Meet our team members. First of all, myself, I'm the project lead. And secondly, I'll be introducing Muhammad Adam Faizal. He is the design and coding lead. Thirdly, Kishore Kumar. He is our simulation and testing support. Fourthly, Muhammad Shazwan. He is our documentation and report support. Finally, Navindran. He is our research and literature review support. Now, I'm going to talk about introduction. So let's begin with the problem overview. Road safety is a significant concern worldwide, with many accidents occurring due to delayed human reaction times. In many instances, drivers fail to apply brakes in time due to distractions, fatigue, or poor visibility. Traditional braking systems rely entirely on manual driver input, which leads to human error, especially in emergencies. Our objective is to create an intelligent braking system (IBS) using Arduino and ultrasonic sensors. This system will automatically apply the brakes when an obstacle is detected, helping reduce accidents and enhancing overall road safety. Okay, now I'll be talking about our problem definition, which is called road safety challenges. The problem we are addressing is the slow human reaction time during emergency situations. This delay can lead to accidents, especially in high speed traffic or poor weather conditions. The traditional braking system are fully reliant on manual driver input, and this creates a significant risk. Our solution is an automated braking system that uses ultrasonic sensors to detect obstacles and automatically apply brakes and minimizing human error and improving safety.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Adam Faisal bin Muhammad Faizal. Right now, I will present about the components and functionality of the system. So, right now we have three component system, which is ultrasonic sensor, Arduino microcontroller, also LED indicator. So, the ultrasonic sensor is to measure the distance to obstacle in front of the vehicle, where the Arduino microcontroller process sensor data and decide when to apply the brakes. And last, LED indicator, which is to stimulate the braking action by lighting up when the brake are activated. So how it works? Continuously measures the distance between the vehicle and any obstacle in the path. If the distance is below a set threshold, the system applies the braking, stops the motor and turns on the LED to simulate braking. Okay, right now we jump to the methodology part, which is system flow and continuous monitoring. So step 1, initialize the Arduino and all components, switches, sensor, motor and LED. Step 2, measure distance to obstacle using the ultrasonic sensor. Step 3, if the distance is below the critical threshold, apply the brakes, turn off the motor and activate the LED. Step 4, if the distance is above the threshold, keep motor running and LED off. So, continuous monitoring. The system constantly check for obstacles and react immediately when one is detected. So right now we jump to the circuit diagram overview. We see the ultrasonic sensor sends out pulses, measures their return time, and calculate the distance. The Arduino process this data and use it to control the motor and LED. The LED represent the brakes and turn on when the system is triggered to apply them. Now is coding part, which is we have three sensors data reading, braking logic, and LED control. So for the coding part, for sensor data reading, the pulse function measures the time taken for an ultrasonic pulse to return, which is then used to calculate the distance. Braking logic, the system checks if the distance is below the threshold. If true, the motor is stopped and the LED is turned on to simulate braking. LED control, the LED is used to indicate when the brakes are applied. So here are some snippets, which is distance calculation and motor control logic.
I'm Kishore Kumar Nagarajan. My matrix number is B0922210131. Now I'll be explaining about the testing and results. So the first one is the testing scenario. Various obstacles were played at 10 cm, 20 cm, and 50 cm to evaluate how well the system responds to different scenarios. The system responded as expected by stopping the motor and turning on the LED when an obstacle was within range. And next one is the result. The system reacted accurately to obstacles and applied the brakes appropriately. Limitations for the system. The system's braking action is binary on or off with no gradual adjustment based on proximity. And it also doesn't distinguish between different type of obstacle. Like for example, a stationary object versus a moving person. Okay, next I'll be presenting the discussion. So the effectiveness of the system performed well in basic obstacle detection scenarios and successfully engaged the brake in response to obstacles. And the next one are the improvements that can be done. So implement proportional braking to gradually apply braking force depending on the distance to the obstacle. Use advanced sensors like infrared or radar to detect obstacles more accurately. And the last one is to integrate a speed sensor to adjust braking force based on the vehicle's current speed.
Hi, my name is Navindran Kalagaran and my metric number is B0922103661. I'm from BMKA 2 stroke 1. So now I'm going to talk about the literature review. So this is the key reference that we got from the Google and the article that for the project that we are doing. So the first one that we got is from the Mr. Singh and Gupta from 2020's journal, and the journal name is Design and Simulation of an Automatic Braking System Using Arduino. This is highlighted for the use of Arduino for the low-cost braking system. The next journal is Mr. Kumar from 2018. Their review on automated braking system provide insight into various sensor technologies such as ultrasonics and radar sensors for vehicle safety. So next is from Yadav and Sharma, 2021. Their journal is Automotive Emergency Braking System. So this inspired our design for making automatic braking system, braking mechanism based on sensor input. So the last one is Baccharia and Burma from 2019. Explored the use of ultrasonic sensor in smart braking system, influencing our sensor choice. And this is the journal from Mechanical Engineering. So next is conclusion. So what we get from the conclusion or the key takeaway is we successfully develop an intelligent braking system that can automatically apply brake based on obstacle detection. The system is simple, cost effective, and significant, significantly improve road safety by automating a critical function of vehicle operation. So the future work is further sensor integration and algorithm adjustment are required to make the system more effective for our real world use. So testing in different environments to ensure the system perform well under various conditions. That's all from me. Thank you.
Before we conclude, we would like to take a moment to express our gratitude to our instructor, Dr. Muhammad Hafiz bin Harun, for his continuous guidance throughout the project. I also want to thank each for each team member for their contribution and hard works. Without everyone's dedication, this project would have been possible. Thank you.
Finally, as a conclusion, this concludes our video presentation on the intelligent braking system using Arduino. We hope our project has provided useful insights into how we can improve road safety through automation. Thank you for watching and we look forward to your feedback. Thank you.